however, in this video we'll discuss about a few built-in functions in Python. In this case, we'll concentrate on math module. Okay, so Python built-in math functions and math module. So Python has a lot of built-in math functions and a math module, for example, extensive mathematical tasks. Okay, so a few inbuilt functions are there, and for extensive mathematical tasks, we have to import math module. Okay, so we can see the example one by one. So first example is, suppose we want to extract minimum value. So minimum within bracket we have to pass the value. So 3.357 minimum value is what? It is 3. We need maximum value. Max within bracket we have to pass the value 357. Maximum value is what? 7. We need absolute value. So minus 3.77, absolute value is what? 3.77. Okay. Suppose we need 2 to the power 4. So we have to write power 2, 4. So 2 to the power 4 is what? 16. Okay. Suppose we need sum. We have to add the elements. So 1 plus 2 plus 3. Where we have to apply sum. So 3 plus 2 plus 1. The answer is what? 6. Divmod, it will return quotient as well as remainder. So if you divide 10 by 3, so 3 3s are 9, 1. Quotient is what? 3. Remainder is what? 1. So divmod return quotient as well as the remainder. Next, rounding off. It's very important. So round 10, 1514. So 10, 1514. So we need only 2 digits. And the next digit is what? It is less than equal to 5. Less than 5. So the output will be what? 10, 15. So it is 10, 1554. But we have mentioned 6. So no worry. It will print the 4. So in that particular number, we significant digit says 0. That means we don't want any floating point. So output will be what? 1723. Are you getting my point? Now suppose instead of 1, if it is say 6, and if you execute it, we can get the answer 10, 16. 10, 16, not 5. Here it is 5 is there. Why it is so? Because the next number is 6, which is greater than equal to 5. So if it is greater than equal to 5, this number should be the 1 implemented. Should be the 1 more. So instead of 1 5, it should be 1 6. Okay. So we can mention it. Suppose we need only one significant digit. So we can write 10, 2. Suppose we need 3 floating point, 3 digit number. So 1.56 that we can change. Okay. So these are a few inbuilt functions. So if you need more, we need math module. So here in that case, we have to import math module, import math. And suppose we need to know everything about the math. So you have to write help math. So you can execute it and we can see the output. So we can execute it. We can see the list of math functions. So in math module, these are the functions, inbuilt functions are there inside the math module. Okay, so we can check it. You can see the output. Next, using math module, we can do square root, ceiling, power, remainder, and trunc. So we just see one by one. Square root of 60, math.sqrt, square root of 64, it is 8. Ceiling value, math.ceil, 1.4. Ceiling means what? Nearest integer value which is greater than this. So 1.4, nearest integer value is what? 2. Acha. Math.floor, floor means what? Nearest integer value which is less than this. So 1.4, nearest integer value is what? 1, which is less than 1.4. So math.ceiling, nearest integer value which is greater than this number, 1.4. 2 is the just more than greater than 1.4. Okay. So if you need 2 to the power 4, here we need 2 to the power 3. So math.pow, POW 2, 3 means what? 2 to the power 3. Suppose we need 4 to the power 8. So here we have to write math.pow 4, 8, 4 to the power 8. Math.remainder, it returns the remainder of that. So if you divide 10 with 3, so 3 3s are 9, 1. So remainder is what? 1. Math.trunc, so it will return the integer part only. So 10, 335, it will return 10. Moreover, we can apply combination, permutation, copysign, distance, exponential, factorial, fmod, fr, exp, and so on. So combination. So we need combination. Suppose we need 10c5. So we have to write math.com. 10c5 is what? 252. Suppose we need 10p5 permutation. So math.perm 10,5. Answer is what? 30,240. Math.copysign. So whatever be the first digit, first number, it should be the number should be the same, but we have to copy the sign of the second number. Second is what? -5. That's why it is -2. Are you getting my point? Suppose if it is the case, if the first is minus, but the second is plus, in this case output will be what? +2. +2, because it will copy the sign of the second bit. Are you getting my point? Okay. Next we can see the Euclidean distance. Suppose we need to know the Euclidean distance between two numbers. So math.distance between two numbers. So two numbers are there, 2, 3 and 5, and here it is 4, -6 and 4. We want to know the distance between these two. So we have to calculate the Euclidean distance. So 2 minus 4 square plus 3 minus -6 square plus 5 minus 4 square. So if we execute it, we can get the answer, this one. So 2 digit, 3 digit, any digit distance, we can calculate the distance. So we can reduce it into 2 digit and we can check the answer. So if it is say this one, and we can execute it, so we can get the Euclidean distance. So what is it? What is that? So 2 point is there, 2.3 and 4.6, 4,6. So the distance is what? 2 minus 4 square plus 3 minus 6 square. So 2 minus 4 square plus 3 minus 6 square. So we can get the answer 3.60. This is the Euclidean distance between 2.2, 3 and 4,6. If you need e to the power something, suppose we need e to the power 3. So you have to write math.exp e to the power 3. E to the power 3 is what? 20.0809. Suppose we need factorial. Okay. Factorial of 6. So factorial of 6 is what? It is 720. Suppose we need to know factorial of 60. So what is the factorial of 60? We can execute it. So this is what? Factorial of 60. Are you getting my point? Suppose we want to know factorial of 600. We can execute it. So this is what? Factorial of 600. Okay. So we can get the factorial value. So to get that factorial value, math.factorial, math.fmod. Okay, so it will return the modulus. So we can 3 is a 9. So remainder is what? 1. So that's why the output is what? What is the output? Can execute it. The output is what? It is 1 remainder value. Are you getting my point? So if it is a, say it is 100, okay, the remainder will be what? 1. And if you put it say 7, remainder will be what? 2. Are you getting my point? So 7, 100. So 7, 2, remainder is what? 2. This is the remainder. Achha. Suppose we need multiplication exponent part of a number. So math.frexp of a number, it will return the multiplication exponent part. So this is the multiplication part and this is what? Our exponent part. Achha. We may also calculate fsum, product, GCD, isfinite, isinf, isnan and isqrt. So we will see one by one. So if you write math.fsum, it will add the numbers. So number will be what? 1 plus 4 plus 5. That is what? It is 10. Production. So this is what? 1 into 4 into 5. That is 20. Okay. So GCD of number 12 in 12,16. GCD is what? 4. Okay. Achha. It will check is it finite? If it is finite, it will return true. Otherwise, it will return false. It is check whether it is infinite or not. It is, since it is finite, it will return false. Is it not a number? But it is a number. That's why it is written false. Achha. So if a number is finite, it will return true, otherwise it will return false. If a number is infinite, it will return true, otherwise it will return false. If it is a nan, it will return true, otherwise it will return false. Acha, sqrt, suppose 1, 2, 3, 4, 5, 6 is there. 1 square is 1, 4, 9, 16, 25, 36. So 30 should be, 30 is what in between 25 to 36. So it will return 5. So it will return 5 here. So round a square root number downwards to the nearest integer. Round a square root number downwards to the nearest integer is there. Suppose if you enter 10, it will return 3. You can check. If it is a 10, it will return 3. Okay, so 10 will be here in between 19 and 16. So near downwards is 3 to the power 9. So the answer should be what? It is 3. Achha. We can apply log function also, logarithm also. So if you math.log, that means what? Log 10 base e. So if nothing is there, that means base is e, natural logarithm. Achha, suppose we need base 10, so we have to write log 10 within bracket 10 means what? It is what? Log 10 base 10. Answer is what? It is 1. So log 10 base e is what? 2,30. Achha, if you write like this, say math.log 1p, that means whatever will be the number, add 1 and apply log with where the base is e. So log 1p 9 means what? Log 10 base e, that will be the answer, should be the same of that. So that's why it is 2.30. Achha. Math.log 210, that means what? Log 10 base 2. So the answer is what? 3.32. Are you getting mad? Achha. Suppose we need something, say number and base. That means what? Log anything where the base is b. So log 8,3 means what? That means what? Log 8 base 3. The answer is 1.89. Constant and their values. So we can use the constant value also. Math.e, it is 2.72. Infinite is inf. Math.nan, return is what? Nan. Math.pi 3.14. Math.tau. So answer is what? 6.28. Okay, so these are what? Constant and their values. Okay, so that we can use it. Sometimes we need this one, math.pi, math dot say 2 pi r square. So 2 into math dot pi and r square. Let r is equal to 2. So we can get the answer. Are you getting my point? So can you do it? Can you do it here? Let the value of r is equal to say 10. So we can print it for 2 pi r square, 2 or only pi r square. Pi means what? 2 pi r or 2 pi r square. So pi is what? Math dot pi into r square. R square. Square means what? Square. We can get the answer. This is what our answer. Pi r square. Answer of pi square. Okay. So in this way we can apply this one. Or we may apply math power. Power also we may apply. Say we may apply power. Math dot power r comma 2. We can get same answer. Okay, so this means what? This means pi r square. You can use any one. Achha. Similarly, we can use sine theta, cos theta, tan theta, radians, degree. So if you write math dot radians, so it is converting degree to radians. So 90 degree associated radians is what? 1.57. Here it is what? Radians to degree. So 1.5708 associated degree is what? 90 degree. Okay. So here converting degree to radians, here converting radians to degree. Similarly, math.sign, here if you pass the radian, so you can see a sine, you have to pass the radian value here. Sine cos 10, you have to pass the radian value here. So if you write radian value of 90, if you return it, we can get a sine 90 is what? It is 1. Cos 90 is what? It is near to the 0. Cos 90 is what? It is 0. Are you getting my point? Acha. Tan 90, that is what? It is also 1. 0.999. So 78574, it is what? 10 45. It is a 45, it is a radian value of a 45 degree. So tan 45 is what? It is 1. Are you getting my point? So we can check it. We can check it, the degrees of radian value of a 45. So what is the degree value of 45? We can check it. Say if it is a 45, then it is what? It is 785. We can check it. It is 7853. So that's why here we pass this, the radians value of a 45 degree. Okay, so tan 45 is what? It is near about 1. Is it okay? Now other useful functions are also there. We can check it. These are the useful functions. You can check if it is required. You can check it. Now Python built-in function. Few built-in functions are there. So we will see one by one. Say all, any, and sorted. All is what? It will return true if iterable objects are there. You can see return true if all items in an iterable objects are true. If all are true. It will any return true if any an item is iterable object is true. If any one of the object is iterable, it will return true. Sorted. Suppose we want to display in a sorted order. 7492, it will return in sorted order. Suppose we want to display in reverse order, in descending order. So here we insert reverse is equal to true. Are you getting my point? Okay. Chalo. Next, filter is there. It's very important. So my list is there, and here we apply shorted form of the function result hold. Here we pass the function and the list. List is what? This one. Okay. So you can put some space so that I can explain properly. Okay. So and the space, we can execute it. So filter, we pass the list, and it will check the element one by one. If it is even number, it will store into the result. Okay, and if you print the result, we can get the 0 to 4. So 0, 1, 2, 3, 8. If the even numbers are 1, 0 to 8. Similarly, we can use like this way also. Suppose filter is there, okay, and here we pass the function as well as the list. So the function will implement on all the data points, and the data will store in the result. And if you print the result, we can get the answer, same answer. Since the task of the function is to know whether the number is even number or odd number. If it is even number, it will return true. So instead of doing this one, what you can do, we can check whether the number is odd number or not, and we can just check odd check. We can odd check, and here we put some value odd. Okay, so in this filter method, we pass the function as well as the list. So we implement the function on all the data points present in the list. So odd check, it will check whether the number is odd or not. If it is odd, it will return true, otherwise it will return false. Okay, so in result, if you print the content of the result, we can get the odd numbers. So that's why this is the use of filter. So it's a very important one. You just see it properly. So here you have to pass the function and the collections. So instead of list, it may be that tuple may be there or set may be there. It's okay, no problem. It will check one by one. Next, enumerate. Enumerate will return the index as well as the value. Suppose my list is there, and if you write for I in enumerate, it will return the index values and associated the element. 0 of the wall, 1 thriller, 2 dangerous. Next is zip. What is the use of zip? Suppose M and F, two tuple are there. The content is Ram, Krishna, Mahadev, female, and F, Sita, Radha, and Parvati. If you write Om is equal to zip, if you apply zip here and if you iterate Om, we can get Ram, Sita, Krishna, Radha, and Mahadev, Parvati. Okay, so it merged these two and iterate simultaneously. One more thing is there, iter and revr string. So if you write x is equal to iter and if you apply next, so it will iterate the content one by one. So iter, Georgina and Hilton. If you print once again next x, it will return the key also. And if you write reversed, so it will return from reverse. So first of all, next y, it will return Kendall, then Sophia. So if you write print next y, then it will return the Selena also. So you can check it. You can check it. Okay, you can see the Selena is there. Okay, here if you once again execute it, you can get the key also. Okay, so this is the use of iter and. Okay, so that is the end of this particular video. Thank you very much.